Welcome to the math record. Today I'll be covering derivatives and exponentials. So similar to the power rule, which works with functions like polynomials, which is if f of x is equal to a variable base and a number exponent, then if we take the derivative, we just have n times x to the power of n minus 1. Exponentials kind of switch the base and the exponent such that we have a number base and a variable exponent. So if we take the derivative of this, the rule for exponentials is that we take the natural log of whatever our number is multiplied by our original function. And that's it. So let's try an example. So let's say f of x is equal to 2 times 3 to the power of x. So 2 is a constant, so we don't have to work with it, as I said before, with scalars. Then taking the derivative of 3 to the power of x, natural log of that number, so natural log of 3, multiplied by the original, so that's 3 of x. So the derivative of our f of x for this one is 2 times natural log of 3 times 3 to the power of x. Okay, so keeping what we had before, where we have a to the power of x and their derivative, it's natural log of a times a to the power of x. What happens if a is the natural exponent, so e to the power of x? Well, e is just a specific case of a. So what we could do, the derivative would give us natural log of e times e to the power of x. Natural log of e is 1. So 1 times e to the power of x, that's just e to the power of x, which is really cool because if your function is e to the power of x, the derivative is also e to the power of x. So usually you don't really need to memorize this formula. All you have to do is just memorize this one because e to x is just a specific case of this formula. Okay, now let's try a example that combines the power rule and with our exponent. So let's say f of x is equal to 5 to the power of x squared plus 2x plus 3. So this seems kind of difficult, maybe, but we could actually take this step by step. So the derivative of this, so we recognize that it has a number base and a variable exponent. So this is actually exponential. So what we have to do, take the derivative of our number, take the natural log of our number, times our original function, so 5 to x squared plus 2x plus 3. Now remember, this isn't just 5 to the power of x. This is 5 to the power of x squared plus 2x plus 3. So there's a function inside of our actual exponential. So basically, if we have a function inside a function, we had to use the chain rule. So we need to find the derivative of what's inside. So we had to find the derivative of this. So the derivative of 2x, x squared is 2x. The derivative of 2x is 2. And the derivative of 3 is 0. So we don't have to write that. So overall, our derivative for this function is natural log of 5 times 5 to the power of 5x 5 to the power of x squared plus 2x plus 3 multiplied by 2x plus 2. Sorry if this kind of looks a little bad, because I want to be clear about this. It's 2x plus 2. This is not inside the exponent. This is outside of it. So we're multiplying like this. So even though we're chaining in the exponent, it's always going to get multiplied outside. And that's basically it for this video. In the next video, I'll cover derivatives with trigonometry. Thanks for watching.